Okay, then we will start. I could see 37 are there. Today also only 4 or 5 of you has conveyed to me that you are not able to join. Remaining those who are not joining, okay, we'll see. But take it seriously. You all have to join unless you have some justifiable reason not to join. So my slides are visible. Yes. Right, sure. Okay. Anyone? My slides are visible.
Yes, sir. Yes.
Okay. Okay, great. Now we'll move ahead. So today we will see probability theory. Okay, in first class, we have seen about basic terminologies we use in statistics. Then in second class, we have seen uh, combinatorics. In that, we have seen permutations, variations, and combinations. Today we will see probability theory. Okay, probability theory. So we'll start. So what does probability theory means? Okay, first thing is that first thing you should keep in mind that while applying probability, you should have some past data or some present data. Okay, you should have some data on which you can work upon to estimate or to judge future events. Okay, that is what probability is. Okay, you should have some existing past or present data. Then what you can do is that by using probability and statistics, we can predict how likely each outcome is and make the right decision in our respective field. Okay, whatever subject area you are working in, you can very well work out how likely each outcome is going to happen. Okay, by using probability and statistics both. So someone may ask that why I'm using probability and statistics word differently. Actually, probability may or may not be directly characterized into statistics because the probability is probabilities comes from a different school of thought. But when we read statistics, we use both these terms synonymously. That those are part of a one subject only. And statistics many times it matches with mathematics also. That's why sometimes we use differently, but many times our understanding is that probability and statistics are under a single umbrella of a subject. Okay. So now what does probability means? Okay, what does probability means? Probability means essentiality. Probability is the chance of something happening. Okay, like you, you are saying that today the atmosphere is uh, cloudy. So you can tell your friend that today it may rain. Okay, so what you are doing is you are expressing probability. You are expressing probability of something happening. Okay, that is a general understanding of uh, general understanding of a probability. Now we'll just see what about now we'll see the academic definition of what second academic definition of probability. It is what it is likelihood of an event occurring. Okay, this event I will just describe you. It is what likelihood of an event occurring. And what does that event means? It is a specific outcome or a combination of several outcomes. Okay, there may be a specific outcome or a combination of several outcomes. It is called event. And likelihood of that event occurring is called probability. Okay, so I hope definition of probability is clear to you. Huh. Okay, we'll see after that. Okay, huh. We'll move ahead. Now the simple example, what all textbooks gives and in class also we use is the flipping of a coin. So suppose if you are flipping a coin, either there will be heads or either there will be tails. So these both the things, these both the things are what these are our event. Okay, it's a simple example of an event. If I'm flipping a coin, either there may be heads or there may be tails. So these are events. Now, when you are going deep into the probability theory, you have to keep in mind that we are not much interested in an event in knowing whether that event is likely or unlikely to happen, but we are more interested in which event is relatively more likely to happen. Okay, these two lines I have written from my experience. This you will not find in any textbooks. So this you keep in mind what I'm saying. When you are doing probability theory, you are not interested in any event whether it will happen or not, but you are interested in which event is more likely to happen. There is a difference between them. Okay, that is what we read in probability. So when you are conducting probability test, usually you work in numbers. So suppose if zero value is there, I would say that there is absolute certainty of the event not occurring. Okay, if if the value is zero, if the probability is zero, I will say that there is an absolute certainty that of that event not occurring. And if it is 1, then means it is absolute certainty of that event occurring. Okay, so all the probability will lie between 0 to 1. 1 means there are 100% chance, 0 means there are no chance. Okay, in between we will see how we'll proceed. So so suppose I am starting from 0. Here you can see I am starting from 0 and here it is 1. Okay, so as soon as or as long as I am moving towards 1, I'm moving towards higher likelihood of that particular event to occur. Okay. So suppose if it is here, I will say that that event has 20% probability to happen. If I'm here, I will say that that event is 50% chances are there that particular event will occur. So sometimes probability is expressed in percentage, as you can see here, sometimes in fractions and sometimes in decimals. All three are same only. 1 by 5 is 20%, 0.2 is 0.2, a fraction, sorry, decimal and percentage. So there are different ways to express probability, but all when you numerically see all are same. So I hope you are able to understand how we are going to express probability. Zero means not at all happen, and as soon as you move towards one, there are higher likelihood of that particular event to occur. And what does the basic aim of probability is? The basic aim of probability is quantifying how likely each event is on its own. Okay, means on its own, based on its own intrinsic property, how that event can occur. Like I'll give you a simple example. Most of you are working in laboratories because this is a basic science lab. So most of you are working in laboratories. You are mixing two chemicals together. With the proof of concept, you know that if I mix chemical A and chemical B, the outcome C should happen. But you cannot change the intrinsic property of that chemical A and chemical B. Chemical A is as it is what it is, and chemical B is as it is what it is. So that's why when I'm saying probability, in probability, I am saying that quantifying how likely each event is on its own. Okay, you cannot if there is a established proof of concept for something, you cannot go and change it because that is what we already it is established. So that's why probability we see how likely each event is on its own. Now we will see the mathematical definition of probability. So suppose now I hope you are crystal clear about what an event is and what an probability is. So A is event and P of A is probability of occurring of that event. Okay, when I'm saying A, I will write mathematical notation as capital P bracket A. A is event and P of A is probability of occurring of that event. And what will be the formula? Formula is very simple. P of A will be preferred by all. Means whatever favorable outcomes we want out of total number of outcomes that may occur. Okay. Suppose I'll go to the previous example, flipping of coin. There are possibly two outcomes only, head or tail, and I want head. So my probability will be 1 by 2. Okay, my probability will be 1 by 2. Every time there are 50% chances. that either head or tail will come out of two outcomes. So probability of a P of A will be preferred outcome divided by all number of outcomes. Preferred outcomes are favorable. That is what we want. And sample space is total number of outcomes which can occur in that particular sample space. Okay. I hope so. I hope mathematical definition of probability is clear to you. Now, yeah, this example just now I told you, flipping of a coin. So suppose I want heads only. So my probability will be P of A will be 1 by 2 equal to 0.5, 50%. And suppose I have a dice, six-sided dice, a cube. I want four on that dice, and total outcome may be six. So preferred outcome is one, total possible outcomes may be six. So there is a probability of 0.167 or 16.7% or 1.6 that 4 will occur on a six-sided dice having numerals 1 to 6. Okay, so probability of A occurring is 1 by 6, 0.1 by 6. These are simple example. So preferred outcomes divided by all number of outcomes. Okay. Now, suppose I want a particular number which is divisible by 3. In a dice, my job is to see what is the probability. Okay, what is the probability? What is the probability of occurring of number on dice on a dice which is divisible by 3? Okay, which is divisible by 3. What is the probability of occurring of a number which is divisible by 3? So see, there will be two numbers only in that. One is 3 itself and second one is 6, which are divisible by 3. Others will be in a decimal format. So in that case, what will be my total number of outcomes? Of course, two, either 3 or 6, right? Either 3 or 6, and total possible outcomes 6. Okay, so in that case, my probability will be 2 by 6, that is 0.33. Okay, my probability will be 2 by 6 because there are two favorable outcomes. My question is, what is the probability of occurring of a number on a dice which is divisible by 3? So either 3 can be divided by 3 or 6 can be divided by 3. Others will lead to a decimal number that we don't want now. We want a whole number. So in that case, my preferred outcomes will be 2 and total possible outcomes are 6. So 2 by 6 equal to 0.33. Okay, 1 by 3. Now here I would like to observe you one thing. Here I had one outcome only, preferable outcome. So its chances were less, 16.7%. But here two outcomes are favorable. So probability is increased by double. Okay, 16.7. Usually it is double and it becomes 0.33. Okay. I hope up to this point it is clear to you. Sridevi, you able to hear me? Sridevi T, are you there?
Hello, sir. Yes, sir.
Sridevi, can you briefly explain what is probability?
Sir, probability is chance of something happening. Like, for example, if a coin, for example, if a coin tosses, there is two possibilities like tail or head. So, if the chance of getting tail is, we can say that it is 1 by 2.
Okay, good, good, good. Sangeeta MS, are you there? Sangeeta. Sangeeta, are you there? Okay. Devika Yadav, are you there?
Yes, sir.
So Devika, what is the mathematical formula for probability?
Sir, 1 by 2.
1 by 2. No, I am asking you general probability formula. What is the, like, what we divide by what in probability?
N by 2.
What? N by 2.
Yes, sir.
No, whether you understood whatever I explained in last 10-15 minutes. What do you understood? Can you tell me, like, what is probability?
The probability is that the chance should be happen or not. The 50-50
Chance should be.
percent.
So how I will.
50% should be happen, 50% should not be happen.
Okay, so how I will denote it with mathematical formula.
Sir, I didn't remember.
Okay, so actually, Devika, first day also I asked you something you are not able to answer, and I suggested you to go to see to it whether you were able to see all those things on internet.
Yes, sir.
Okay, so uh, today itself I'll be uploading the recordings. You all have to answer in some or the other way. Okay, you don't think that it will be just like that. And those who are not attending, you convey to them that take it seriously. When I'm saying you have to attend, means you have to attend. Now also 39 are there. So probability is basically, I told you now, a favorable outcome divided by total number of outcomes. It is the formula for probability. 1 by 2 and all is the afterwards things. Okay, Devika.
Okay, sir. So favorable outcomes divided by possible outcomes in.
Yes, preferred by all. A is the event. You can see on the screen. P of A is the probability preferred by all. Okay. Okay.
Okay, sir.
So now up to this point, I have explained you about events. Then what is the general definition of probability? What is the academic definition of probability? All those things I've explained you. Now we will see some different types of events. First one of those events is independent events. Okay, first one of this is independent event. So in independent events, we will see that whether there is a probability of event A and B together happening. Okay, A is independent, B is independent, but whether together they are happening or not, that we see in independent events. And the formula will be simple: probability of A into probability of B. Means both are separate. Okay, both are independent. But when we multiply them, we will get the probability of together whether they will happen or not. Like in cards. Okay, there will be S, then there will be spade. So it can come separately, the one number, and this particular color will come separately. But when we multiply them, we can have a independent event that that number is coming out of a deck of cards with a particular color. Okay, with a particular color. So this is how we calculate independent events. Okay, so one more example, what I can give you is that suppose there are two dice. There are two dice. Dice one, dice two. And here you want to see probability of occurring on 2. Here you want to see probability of occurring 3. So both the dice are independent. The outcome of one die is not dependent on the other. But if you want to calculate probability of 2 and 3 occurring together, we can multiply the probability of occurring 2 on one dice by the probability of occurring of 3 on other dice. If we multiply both, we will get the probability of together events. Okay. Now we will see about the expected value. Now, what does an expected value means? By now, we discussed about probability, we discussed about events, we discussed about independent events. Now we will see expected values. What is an expected value? Expected value is the average outcome we expect if we run an experiment many times. This is the catch here. This is the thing which you should keep in your mind. The average outcome we expect if we run an experiment many times. Okay, average means, let's say I am doing 10 times. And my norms and my standards at laboratory say that unless it is positive in 7 out of 10 cases, we will not declare it as positive. Like COVID, in RT-PCR, there were different norms. Someone was saying that unless we get continuously in 30 cycles of RT-PCR, the gene of COVID, will not declare it as COVID. Then it was reduced. Okay, like that I'm saying. So that is the expected value. So the average outcome we expect if we run an experiment many times. That is called an expected values. Now I want you to understand between two things, trial and experiment. So suppose if I'm flipping a coin one time, if I'm flipping a coin one time, I flipped it and I have recorded the outcome. That particular one time doing is known as trial. Okay, that particular doing one time is known as trial. But if I am repeating this trial many times, then it has become my experiment. Okay, so whatever you people are doing experiments in your lab, first time someone would have done some trial, but when you are repeating it, means you are doing experiment. So experiment is nothing but multiple trials. Okay, experiment is nothing but multiple trials. So how I will explain you this? Suppose you have tossed coin 20 times and you have record 20 outcomes. So you will say that it is a single experiment with 20 trials. Okay, it is a single experiment with 20 trials. Coin toss, you have done 20 times. You have recorded the outcomes 20 times separately. So it is a single experiment with 20 trials. So in this case, what will be the experimental probability then? It will be P of a successful trial upon all the trials. Suppose you want a favorable outcome. Okay. So out of those, whatever your successful trials are there, suppose this coin example only, you want at least 8 times head should come out of 20 times. So 8 by 20 will be your probability. Okay. P of a in this case will be successful trials divided by all trials. Now, I already told you how we show it with mathematical convention is E of A. E of A, the outcome we expect to occur when we run an experiment, that is expected value. Now it's a simple example. Suppose I want this particular card with black color and A. Okay, so in this case, if I want to see a categorical outcome, my expected value will be E of A will be P of A into N. Okay, P of A into N. Okay, how I will see it? Total cards will be 52, right? Total cards will be 52 and spade is 13 out of that. So the probability of spade from 52 will be 13 by 52, right? Favorable outcome upon total outcomes. That is 1 by 4. That is 25%. 0.25. Now suppose I did it 20 times. I shuffled it 20 times and I took 20 times card. So in that case, this 0.25 I will multiply by 20. So the probability of this particular card with particular spade color and number will be 0.25 is the one time and 20 times I am doing it. So 5. So my expected value will be 5. So I can say that 5 times out of 20 times it is expected that get the I will get the this particular card. Okay, so I hope expected values are clear to you. Lakshmi Shaji, are you there? Lakshmi Shaji?
Yes, sir.
Oh, so what is the difference between a trial and an experiment?
A trial and actually, uh, we can tell it with the example of a coin. If we are
Yeah.
once flipping a coin and recording the outcome, we can call it as a trial. And if this same one, if we are flipping the coin multiple times and repeating it, and then this
Hmm.
multiple trials come, we call it as an experiment.
Okay, good. Reshma here, are you there? Reshma,
Yes, sir.
you able to hear me, Reshma?
Yes, sir.
So Reshma, can you define expected values?
It is the average outcome we expect if we run an experiment by many times.
Your voice is too low. Anyway, I think you are outside. Okay, we'll proceed. So I hope up to this point, expected value, trial and experiment, independent event, all these things are crystal clear to you.
Hello, sir.
Yes, yes. Who is this?
Sorry, this expected value is coming under in the case of an independent events. If you are taking probability of independent events only, then this expected value come or not.
Yes, yes, yes. Who is this? Reshma?
No, sir, Anjana.
Anjana. Ah, okay, okay. Good, good, good. It was a good example. And I appreciate you that you were able to connect that it is from an independent event. Good. Okay, we will proceed ahead. So now suppose I want to see this one. Okay, go ahead. Go ahead, go ahead. I will join up. Okay, so now we will proceed with numerical outcomes of an expected value. So suppose I have a sample space of ABC. Okay, the previous example what I gave you was a simple example that out of 52 cards, 13 will be spared. And if I'm doing 20 times, there are chances that 5 times it will come out. Now here suppose some complex system is there. Okay, some complex system is there. So suppose if there is a sample space of ABC, there is a sample space of ABC. So my overall outcome will be A into probability of A, B into probability of B, C into probability of C. This I will explain you with an example. Okay. So in this case, my sample space will be equal to all the outcomes. Okay, my sample space will be equal to all the outcomes. This I'll explain you with example, then you will understand. So, suppose there are three rings in a particular target ABC. There are three rings in a particular target ABC. So if I'm hitting a target at A, I will get 10 marks. You know, na, when there is shooting competition, the more closer the more closer you are to the center, the more marks you will get, the more score you will make. It is like that only. So if you are hitting on A, you will get 10 marks. If you are hitting on B, you will get 20 marks. And if you are hitting on C, you will get 100 marks. Okay, you will get 100 marks. So suppose the probability of A is 50%, 0.5. Okay, probability of A is 50% that out of one shot, 50% probability that it will not hit B or C, but it will hit A. Okay, and probability of B is 40%, and the probability of C is only 10%. Okay, only 10% because that is the target, and that will be the difficult one. So in this case, my expected value will be 0.5 into 10. Okay, 10 into 0.5, then 0.4 into 20, and 0.1 into 100. As I told you earlier, in that case, the total expected value will be like A into PA, B into PB, C into PC. Okay, so now I will calculate this and my expected values comes around 23. Okay, my expected value is 23. But there is one catch in this. My expected value is working out as 23. Okay, but can you see 23 score here? Your authorities can only give you 10, 20 or 30 or 100. 10, 20 or 100. This probability you have calculated independently with the method what I have briefed you earlier, that you have calculated independently and you want to see the expected value. So whether your authorities will be able to give you 23, no, but still you are getting an expected value of 23. So I will not brief here now, but I will move ahead, then you will explain. You will understand. So, okay. So, no, it is this I have already told you. We can use expected values to make predictions about the future based on past data. So, in those cases, many times we require frequency. Okay, many times we require frequency. Why? Why we need frequency? Many times, and this you will not get in book. This is my experience only. sharing with you. You just listen to it properly. Many times the expected value are confusing and sometimes the expected value does not make much sense. You yourself think, when my authorities cannot give me 23 marks, how my expected value can be 23? But expected value is just giving me an near to rank a possibility. That if it is 23, means I can say that it may be B, but it cannot be exactly B. Alright. So in those cases, we require frequency. Those cases we require frequency. So I hope it is clear to you that many times the expected values are confusing and sometimes the expected value does not make much sense. In those cases, we require frequency. Now, I will give you one example of two dice taken together. So in first die, there will be 6 options with me, right? In second one also 6. So total outcomes may be 36. As per the last class, combinatorics, I tell you that there is no foundation of repetition or anything. So there will be 36 outcome. Right? 1 1 1 2 1 3 1 4 1 5 1 6 2 1 2 2 2 3 2 4 2 5 2 6 like that. So in those cases, how we will work out our expected value, that we will see now. Suppose this is the outcome matrix. This is a outcome matrix. Okay, this is the first dice. This is the second dice. Okay, this is the first die. This is the second dice. Here 1 2 3 4 5 6 can occur. Here 1 2 3 4 5 6 can occur. And in between sum is mentioned, like 1 plus 1 2. Okay, 1 plus 1 2, 2 plus 1 3, 3 plus 1 4, 4 plus 1 5, 5 plus 1 6, 6 plus 1 7. Similarly 1 plus 2 3 4. Okay, like that sum is mentioned. Okay, so here what we will see, we will try to see through some angle how we will be obtaining the sum. Okay, so the total number of outcomes for sum of two dice thrown together. Suppose I want to see example of two dice taken together. Two dice are taken together with probability of getting a sum of 7. Okay, probability of getting a sum of 7. So in that case, I have to count now. I have to count. So where all 7 is there, I have to count. So 1, 2, 3, 4, 5, and 6. So there are 7 chances that we will get a sum of 7 when we throw these two dice. Okay, there are 7 times that chances will be there when the chance will be there when we'll be getting a sum of 7 when we are throwing two dice. So favorable outcome 6 and total possible outcomes 36. Right? Total possible outcome 36 only. So 6 by 36, 1 by 6. So probability of getting a sum of 7 is P of 7, 6 by 36, 1 by 6. Okay. Now, in this case, probability of expected value EA, P7 will be 1 by 6. So it is the most probable answer. It is the most probable answer, but it's still very unlikely. Okay, still very unlikely in when I'm talking about expected value. So now I will tell you some other thing. Now I will come to a particular point. Frequency. Okay, up to this point, I hope it is clear to you that I wanted to see a probability of getting a sum of 7 and it was 1 by
Excuse
6.
me, sir.
Yes.
Sir, this is Aarti.
Who
Sir,
is
I
this?
couldn't. Aarti.
Yeah, tell me, Arti.
Sir, could you please explain this once more? I couldn't get it.
Oh,
Like the
sure, sure.
probability
Why
of getting
not? Why
7
not?
is 6, right?
What?
I got a confusion. Can you just explain it once more? Just briefly.
From where? This previous example, no?
This one, sir. The
This
next
one,
slide.
this with the okay. Okay. So actually, what we are doing is that, okay, I'll just give you a brief earlier also. Up to this point, it is clear to you that when I'm calculating an expected value, it may give some output, but it may not be the exact output what is feasible with our authorities or what is feasible with our norms. Is this clear to you?
Yes, sir.
Means expected value is 23, but I have a score of 10, 20 or 100. So that is the reason we need frequency. Up to this part, it is clear to you?
Yes, sir.
Okay. So before frequency, I gave one more example that if suppose two dice are there, two dice are there. Okay. Two dice are there and I want to see the expected value EA. So here two dice if I'm throwing, here will be outcome of 1, 2, 3, 4, 5, 6. And here also will be outcome 1, 2, 3, 4, 5, 6. And this matrix is the sum. This matrix is the sum of these two, like 1 plus 1, 2, 2 plus 1, 3, and like on. Okay. So this is also clear that the central portion is the sum of the vertical and horizontal row at that particular block. Aarti?
Yes, sir. Yes, sir.
Like if I'm seeing this 7, so this 7 is the sum of this 4 and this 3. Okay, so this is 7. Like this is the sum of the dice. Now here the question was example of two dice taken together and probability of getting a sum of 7. Okay, probability of getting a sum of 7 that we were trying to find out. Okay, so here we have seen that 7 is coming 6 times. If I'm throwing a dice, if I'm throwing a dice, so it is there at 7 times. 1, 2, 3, 4, 5, 6. So my favorable outcomes will be 6, right? Favorable outcomes will be 6 and total possible outcomes will be 36, right? 6 into 6. So 1 by 6. So again, 1 by 6 is the most probable answer, but still it will be very unlikely. Why? Because if suppose by chance you are throwing a one dice, only one, and you want an outcome of 1, that probability also will be 1 by 6, right? That probability also will be 1 by 6. So in this case, you cannot categorically say that, yeah, this will be same for both. But on the contrary, getting a sum of two dice 7 is a different thing. Getting a 1 is different thing. And 1 by 6 can be a probability for other configuration also in this, right? It can be for other configuration also. So here I'm only able to say most probable answer. Okay, I think this is where you got the confusion.
Yes, sir.
So the thing is that you may be thinking that what is wrong in this? 1 by 6 is 1 by 6. I'm getting probability. But what I'm trying to say, when you are going with your practical convention, when you are doing some experiments, that may be the same case for other experiment also. Then how you will be able to categorically say that this probability is for a particular outcome only? For that only we need frequency. Okay.
Okay, sir.
Hmm. And also when you are reading it again in the previous, like when subsequent we are moving, it will be clear to you that why it is unlikely and why probability is only a most probable answer. So in this case, what we will do, so of course, as I mentioned earlier, expected values does not make much sense, and we are also not able to generate an interval for prediction. Okay, when I'm making a prediction, I should be able to say that it will be between this and this. Right. So in the previous case, I'm not able to make any prediction. That's why we need a probability frequency distribution. Okay. That is the reason we need probability frequency distribution. So what it is a collection of probabilities for each possible outcome. Here you have to keep in mind, it is a collection of probabilities for each possible outcome, and it is denoted by a graph or a table. Okay. It is a collection of probabilities. So now suppose I want to make a probability frequency distribution for the previous example where two dice outcomes I have given. Now you see, this is very important. Okay, just listen to it. This is the same table what I have shown you earlier. Okay. Now what we will do here, we will divide the frequency by total number of outcomes. Okay, so we will get the probability. Let's say I want a sum of 2. I want a sum of 2. Okay, I want a sum of 2. So 2 can occur one time only. Right? You can see here 2 can occur one time only. So its frequency is 1 and probability will be of course 1 by 36 because total number of outcomes 36 is fixed. Okay, total number of outcomes 36 is fixed. Now sum of 3. 3 I can get 2 times. You can see here 3 I can get 2 times. Nowhere else we will get 3 2 times. So the frequency is 2 and the probability will be 2 by 36. That is 1 by 18. 2 by 36 is 1 by 18. Now sum of 4. Sum of 4. 4 I can get 3 times only. 4 I can get 3 times only. Frequency is 3. So 4 by 4 by sorry 3 by 36. 3 by 36 is 1 by 12. So probability 1 by 12. So I hope this is getting clear to you. Here I'll see sum, then I'll see how many time it can occur and divide by 36. Okay, and you can observe one thing. It is in reverse chronology. Reverse one. 1, 2, 3, 4, 5, 6. Then 5, 4, 3, 2, 1. Because as soon as we are going towards end, diagonally it will reduce. Okay. Diagonally it will reduce. And since these numbers are same and total outcomes are same, here also probability you will see like that. 1 by 36, 1 by 18 up to this point. Then again it will reverse and it will be same. So first and last is same. Second and second last is same. Third and third last is same. Like that. Up to this point it is clear. I hope it is clear to you. Now I will create a table out of it. Okay. Now I will create a table out of it. Now you see here I am making a probability. So some probability of getting a sum of 2. Probability of getting a sum of 2. 1 by 36. As you know, in previous table I have already told you 1 by 36. Then probability of getting a 3. 2 by 36. Already I told you. Probability of getting a 4. 3 by 36. That also I told you. 5 like this. So it is creating a graph. This type of graphs you would have seen many times in your work also, but I hope today you are able to understand how they would have generated this graph. Okay, because I believe in basics only. If the basics are clear, other mechanical things you can always do. But you should know the core, you should know the origin of anything, how it would have been conceptualized at first place. So if the fundamentals are clear, you can very well learn anything afterwards. So in this case, now I would like to draw your attention to something. What I told you earlier is that 1 by 6 may be a most likely answer, most probable answer. But here I am not able to see a range. You yourself think if this 23 was there, if this 23, if at all I was able to give a range for this 23 that it should be between 20 to 50, then I could have chosen 20, right? I could have chosen 20 because 23 itself is a single number is does not making any sense to me. I could have chosen 20. That is the reason we have seen it in a deeper way. And now we have come to a particular probability frequency distribution where we can give it an interval. So what we will be seeing is that the highest bar are equal to highest probability. So when I'm reporting it, this I will report anyway, but I will report with the -1 bar plus 1 bar means the previous bar of that plus 1 bar of that. So in this way, I will at least have a range. Okay, I will at least have a range of working in that particular thing or making any prediction. Okay, this thing is clear to you now. Okay, so
Sir,
yes, yes, go ahead.
sir, can you go to the previous table that sum frequency and probability?
Yes, I'm already here.
Sir, I understand how get 1 by 36, but how we get 1 by 18?
1 by 18 because may I know who is there?
Devika, sir.
Devika. So Devika, what is the formula for probability is total number, sorry,
Sir,
favorable outcome
it's or possible.
upon total outcome, right?
Yes, sir.
This much is clear. Favorable outcome divided by
Yes.
total outcome. Huh. So in this case, total outcome is 36 always. In this case, because 6 into 6 only total outcome will be 36. Up to this point, you are agreeing that total outcome is
Yes, sir.
36. Now you see, I want to obtain a sum of 2. I want to obtain a sum of 2. Now, how many times in this particular rectangle here, what I am drawing with a red line, how How many times you are seeing 2? Just see and tell me.
One time.
One
Time,
time.
sir.
This first one. For first one, right? So my probability in this case will be 1 by
Yes, sir.
36 because this is my favorable outcome. Now the sum of 3. How many times you are seeing 3 in this table here?
2 times, sir.
2 times. This one, right? Where I am drawing a red one. Right? This 2,
Yes,
3.
sir.
So in that case, my probability will be 2 by 36. So when you divide 36 by 2, it will be 18 and numerator become 1. So it is equal to 1 by 18. Okay?
Okay, sir.
So this is
Yes,
1 by
sir.
18. Similar. Now you understood, na?
Yes, sir.
Now in this case also 4 is coming 3 times. So 3 by 36. 3 by 36. Okay, I want to make numerator 1. So I will divide 36 by 3. When I divide 36 by 3, it is 12. So it will be 1 by 12.
Yes, sir.
है ना? Okay.
Okay, sir.
So I hope up to this point it is clear to you why I am making a frequency distribution table, because I cannot explicitly mention any one value, but I want to give a predictive range. Okay, I want to give a predictive range for that particular thing. That's why I am using a probability frequency distribution instead of going for the expected value. Anyway, expected value will be there always, but we will use it differently. Okay, we will use it differently. Now we will see complements. Complements is nothing, but you yourself think, if I am saying that there are 60% chances that today it will rain. So in that sentence, in the same sentence, I am also saying that there are 40% chances that it will not rain. Right? Anything can be 100% only. Right? When I'm talking in percentages, the highest percentage will be 100 only. Out of 100 only I have to say. If I am saying a event can occur with a probability of 65%, I can very well say that A event will not occur with a probability of 35%. So suppose this is your total sample space. This is your total sample space. So A is event of occurring and A of C complement. Everything the event is not. Right? Everything the event is not. So there are ample examples for that. I given you for rain. And if suppose I'm flipping a coin, and the probability of obtaining head is 50%. So at the same time, not obtaining also is 50%. Right? This is known as complements. And this is useful when you are doing examples. When you are doing examples that you will see in subsequent classes. So A plus A complement will be equal to sample spent. Means everything which event is and everything which event is not. Together sum will be our sample space for total favorable outcomes. Okay. So I hope this is clear to you. Now, of course, complements is like all possible outcomes may be ABC. So P of A plus P of B equal to sum of probabilities of A and B. Okay. And if all three are there, so probability of A, probability of B occurring and probability of C will be 1. So if three elements are there and if I want to see three events together, of course their probabilities will be 100% only. 60% of the time there are chances, 60% chances that today it will rain. So ultimately there are 40% chances that it will not rain. So it may rain and it may not rain is equal to 100%. No? Both the things we have covered. I have given a general comment. It may rain plus it may not rain. It is 100% true. It may rain also, it may not rain also. But if I am saying explicitly 1, then I will report it in percentages. So we are 100% sure that whether it will rain or whether it will not rain. 100% sure. Any one of event will occur only. Right? Now, we just will see the coin toss example. Let's say head is A and tails is B. So probability of occurring of A plus probability of occurring of B will be 1. So we have exhausted all the possible outcomes and we are 100% sure that either head will come or tail will come. Okay. So in this case, how we show it in mathematically? A rolling an even number, A dash not rolling an even number. Okay. Okay. Rolling an even number, not rolling an even number. Means basically we are saying that it is rolling an odd number. So a dash will be 1, because if you see out of 6, 3 will be even number and 3 will be odd number. 1, 3 and 5 will be odd, and 2, 4, 6 will be even number. So of course at a time either even number will come or odd number will come. So together it will be 100%. Okay, so so I told you in my previous slide that complements are useful when we want to see opposite situation and we want to solve certain example. So here we'll see an example of rolling a die. Okay, now you all agree to me that if suppose probability of getting 1 from a dice is 1 by 6, 2 is also 1 by 6, 4 is 1 by 6, 5 is 1 by 6, and 6 is 1 by 6. Here I have not taken 3. I have not taken 3. So probability of getting all this is 5 by 6. Means if I'm rolling a die 6 times, 5 times I may get either 1, may get 2, get 4, 5 or 6. Now suppose I want to see for 3. I want to see for 3. No, no, B dash. I want to see for 3. You can see the probability of B dash. It will also be 6. And what I can do is that I can simply uh, minus this probability of B occurring from 1. So I'm getting 5 by 6. Now you yourself see, you are simply minuses instead of writing this many terms. Instead of writing this many terms, you simply minus the probability of occurring of the negative thing what we don't want, that complement. And you have minus it by 1. So you are getting 5 by 6, which is the actual answer. So in certain cases when the calculation is going long, what we can do is that here I don't wanted 3. So I calculated 1 by 1. So what I simply did, I calculated for B and I subtracted it from minus. Probability of having a B 1 minus PB minus. So I can work out the same answer in a short way. That's where complements come into picture. Okay. The same thing what I explained to you. Probability of occurring 1, 2, 4, 5 and 6 is equal to a probability not occurring 3. Alright, because 3 is not occurring here. And the same thing 5 by 6. So, okay, actually I have to go somewhere in an important meeting. Just now I came to know. Today I'm stopping my class here. Next, the other timing I will let you know. So before I leave, if any one of you are having any doubt, you can please ask me now. Or if you wish me to explain something again. Anyone? No?
Sir, I have a clarification, sir.
Yeah,
This is
please go
Balaji.
ahead. Yeah.
So, just want to confirm that whether my understanding is correct or not. For the last one, where you have mentioned about complements. Complements, rather than we are calculating for the all possibilities, we are calculating the negative one, which is which we want to exclude one. That one we are calculating to get the exact probability. Is that correct, sir?
Yes. Correct.
Okay.
100% correct.
Okay. That's
Okay,
clear.
yes, sir, it is 100% correct, because many times if you calculate 1 by 1, the calculation will go long. So you are
Yes, sir.
seeing from other angle.
Okay.
Simply
Okay.
like that.
Okay. Fine, sir.
Anyone else?
Hello, sir.
Yes, go ahead.
Sir, it's not a
Who's
doubt,
this?
sir. Sir, I'm
Ah.
Kavya.
Go ahead, Kavya.
Yeah, sir. So during the class, most of the time we're just listening and we have not like written down all of the stuff that you have taught us. So apart from the
Yes.
class recording, will you be sharing the PPT also with us, sir?
I think sharing the recording will serve the purpose, because anyway whole PPT is there in that.
Okay, sir. Fine.
No, you tell me if you wish, I can convert it to PDF and I can share. Earlier I have shared it all. But the
Then it would
thing
be
is
more
that
helpful, sir, because the class, if you're like not comfortable with the concept, we can go like listen to it once more. That's more easier. But in case of note-wise studying, or like even if coming to assignment, when we are trying to do the assignment, as in such notes we don't have, no. So a little bit of
yes.
difficulty was there. So if it is
Yes.
possible to get the slideshow as in such as a PDF or something, it will be very easy, sir.
Okay, okay. I will share. Earlier also I have shared, but what I have observed is that that it was of no use. That's why I didn't share this time and I am recording. But if you are saying, I can share. I can convert
Thank
it
you,
to a
sir.
PDF and I'll share.
Yeah. It will be helpful, sir. Thank you.
Yeah. But one more thing, I
Yes, sir.
request you all to go through. No, not you alone, but you all that you should go through YouTube videos also, because in that I have recorded it for some group. It's called Keep Learning. So I have taken it more professionally. But the
Yes, sir.
concepts
The
are same.
YouTube
Everything
videos,
is same.
yeah, we are watching it parallelly, but just for the note sake, I'm asking, sir, not for the class.
Yeah, I will give you. I
Class.
will give you. What I'm trying to say is that the exam will be from YouTube plus assignments plus
Okay, sir.
class. Out of that,
Got it.
I will not ask any new numerical also. All numericals, all theory,
Okay.
all concept will be from all these 3-4 things only. Okay, so
Okay,
exam
sir.
may not be a very hard thing for you. Only thing is that all these things you just see to it cautiously.
Sure, sir. Thank you.
Welcome. Anyone else? If no further doubts are there, then I'll leave. Okay. I'll share the recordings today itself.
Thank you, sir.
Welcome.